section is called 4-6, and it's called graphs of y equals tangent of x and y equals cotangent of x. So if I were to graph a tangent function, and I go like this and like this, and I'm going to put in some asymptotes. Asymptotes. How do you do that with this thing? Ooh, let's make these. Let's make it a different color. Green asymptotes. And, ooh, that's nice. That's nice. And we're going to call this x equals pi over 2 and x equals negative pi over 2. Negative pi over 2. And you'll see in a second why I put those things there. They should be symmetric about the lines y equals y. But so what's the tangent of 0 radians? Y over x. So if I'm looking at the point on the unit circle, 0, 1, comma 0, what's the tangent of 0 radians?
0.
0, okay? So the tangent of 0 is 0. So right here at 0, I have a point at 0, right? The next point I'm going to pick is the tangent of pi over 4, because it's halfway between here and here. So this would be pi over 4. What is the tangent of pi over 4? You should know that one tomorrow. What's the coordinates at pi over 4? Root of 2 over 2, root of 2 over 2, right? So that divided by that gives you out what? 1, okay? So right here at pi over 4, you go up to 1. Then as with a tangent function, as the ratio of the opposite side to the adjacent side gets closer and closer to pi over 2, what happens to that ratio? It gets infinitely large, right? Because when you're almost straight up at pi over 2, the opposite side is really big, right? And the adjacent side is really small. So what happens as I approach pi over 2 is this thing gets bigger and bigger and bigger. At 60 degrees or pi over 3, they would be root of 3, which is 1.7, so somewhere up here. And then it keeps going up like that, and you end up on this side going like this, and pi over 2, it never touches pi over 2. That's an asymptote because it goes to infinity right there. Now the reason I don't continue over here is because the graph is just going to look the same after I get to the right side of pi over 2. So it's actually going to look the same as it would over here. And so what I do is I go backwards to pi over 2, and it wouldn't be a function, it would be discontinuous. So you want it to be a continuous function. So what happens over here when I get to, what's the tangent of negative pi over 4? That would be negative 1, okay? So I'd have a point here at negative pi over 4, negative 1, and so then it kind of looks like a little squiggly thing that goes like that, okay? Look at all those pretty colors. Are those pretty? And tangent is periodic, just like sine and cosine. And it repeats itself like that every pi radians. Okay, so it's going to do this again, and it's going to do that. Whoops, what did I just do? Report the tau. What did I just do? Help me. I know what I did. This needs to close. This needs to close. We need to go back to here. And this needs to get bigger. There we go. Okay. So, and this needs to go away. All right. So, unlike sine and cosine, y equals tangent of x has a period of, what's the period? The period is pi. Okay, not 2 pi. It repeats itself every pi radians. Okay, Allie? And with this, remember with with sine and cosine, P is equal to 2 pi over B. In this case, the P is equal to pi over B. And conversely, B is equal to pi divided by the period. So this is the number that goes in front of the x. That tells you how many cycles it's doing in pi radians, okay? And P is the period. So when we get to squishing these things, well, I'll do some examples like that. The other thing is you have asymptotes. Asymptotes at x equals multiples of pi over 2, right? So, or odd multiples of pi over 2. So you would write that pi over 2 plus n times pi. Does that make sense? X equals, where n is an integer, but n can't be an even integer. N has to be an odd integer. Odd integer. You know what I mean by odd integer? No, it can't be. Oh yeah. No, it doesn't have to be an odd integer. It could, because if n is 1, no, that's n is just an integer. Sorry. N is any integer. So if I put a negative pi add to that, it's going to put me over here. If I put a negative, so in other words, every pi, I get an asymptote. Okay. Also, domain is almost the same as the asymptotes, except there's a not equal sign. So the domain is x is not equal to pi over 2 plus n times pi, where n is an integer. N is an integer. And then I have intercepts. Every multiple intercepts, x-intercepts, intercepts at x, intercepts at x equals 0 plus n times pi. Right? Because here's an intercept right there. Here's another intercept, and that would be at, if this is 0, 1 times pi would put me at pi. Okay, and if I had another intercept, negative 1 times pi would put me at negative pi. So if I want to do another cycle of this function, it would kind of go like that. Yes? N is an integer. N is any integer, and an integer is any. An integer is a positive or negative whole number. Right?
Wait, does that say
0
0 plus n pi?
plus n pi.
Why is it 0 plus n?
I guess it could just be n pi, right? But I like, because it starts at 0 and then it adds, just kind of show. Okay? The range, what's the range? How high or low can tangent go? Range goes from negative infinity, negative sideways 8, up to positive sideways 8. Okay? With curvy brackets on the end, because it goes on forever. Questions about tangent? And the other thing, on your calculator, if you graph y equals tangent of x, let's just do it. Y equals tangent of x, tangent of x. Go away. Will it make all that other stuff go away? No. Delete. Oh, let's just say clear. Clear y equals tangent of x. I'm going to do a zoom trig. Let's see a zoom trig, see what that looks like. Trig. There it is. In some cases on some of your calculators, it graphs the asymptotes. So don't think that the asymptotes are part of the function, okay? So I don't know how to turn off the asymptotes. I can look it up, but on some calculators, it graphs in the asymptotes, and there's a way to turn it off, and I forget what it is, okay? That's pretty cool. Very nice. What is that? Desmos?
Yeah.
Yeah, Desmos will do it for you too, but you can't use that on a test because I don't want to use it. Okay, so that's y equals tangent of x. Now we're going to look at y equals cotangent of x. Y equals cotangent of x looks real similar to y equals tangent of x, except it's kind of a little different. We don't want to do it. Okay? So y equals cotangent of x. This is x equals pi. What's the cotangent of 0? Cotangent of 0. What's x over y at 0? X over y, cotangent, at 0 radians. X over y. 1 over 0, right? Here on the unit circle, we're at the point 1 comma 0. So 1 over 0 is undefined, okay? So cotangent of x starts up here, okay? And at pi over 2, this goes to 0, because then you're talking about x over y would be 0 over 1, right? So that would be 0, and it kind of starts up here, and it looks like tangent, except it goes this way, okay? And tangent and cotangent are both 1 at 1 and negative 1 at pi over 4, and then again at 3 pi over 4. So you have a point at negative 1 at 3 pi over 4, and then you have a point at positive 1 at pi over 4. And that's what y equals cotangent of x. So cotangent starts at y equals 0 and works its way over to pi, okay? And it starts from the top and goes to the bottom. Tangent starts from the bottom and goes to the top, and it goes from negative pi over 2 to pi. Okay, so they're kind of similar, but they're kind of different. Captain, put your phone away. Thank you. All right, so the period again is pi. Period again equals pi. Domain is x is not equal to what? What's x not equal to? 0 and pi, right? So multiples, x is not equal to n times pi, right? Any multiple of pi, you have an asymptote. And that's the same for the asymptotes. You'll have asymptotes at multiples of pi. You have zeros or x-intercepts, sometimes they're called. Zeros and x-intercepts are the same thing at multiples of pi over 2, okay? So zeros at x equals pi over 2 plus pi n, right? N pi. Like that. And the range is the same, and so on and so forth. And so again, like tangent, this is going to repeat itself every pi radian. So I could draw another cycle of it right over. Whoops, what happened? I had drawn another one, and what would this be right here? What would this be? X equals what? Negative pi. Okay, so it repeats itself every pi just then. Okay? Tangent, cotangent, not so hard. Now we got to do some stretches and shifts of them. You ready?
Maybe.
Do you want to hear a joke?
Yeah.
Sure.
I don't have any.
Oh.
How about?
Unless that's the joke.
Do you know how to catch a polar bear?
With a really big net?
No. I have to be off the air for this one. Okay. Let's. Sorry, I like that one. Okay. I can't get fired for telling that joke. That's okay. They can fire me. Okay. So anyway, let's sketch by hand. That's so sketch. Right? Sketch y equals negative 3 tan of 2x. Could you sketch that by hand?
Maybe.
Yes.
Catherine! Okay. Negative 3 tan of 2x. So the period. So what I would do is start by finding the period. So unlike a sine or cosine function, the period is pi over b. Okay. What's b in this case?
2.
So in this case, it's pi over 2. So this function is going to complete one cycle, not in pi, but in pi over 2. Okay? So there's no shift or anything like that. It's a negative tangent function. So I'm just going to start by graphing it and putting in some asymptotes. That's what I would do first. I don't like the dotted line, so I'm going to try that again. Make a solid line. Okay? So here's the line. Here's the line. And because the period is pi over 2, instead of going from negative pi over 2 to pi over 2, can anyone tell me what I should use as my asymptotes?
Pi over 4.
Very good. Who said that?
I said that.
Very good, Miguel.
Yeah.
Good. So, so Miguel said correctly that it should go from pi over 4. I don't want to do, now I want it dotted line. Okay, dotted line, make it green. So I want to go from negative pi over 4 to positive pi over 4 because the period is pi over 2, right? So between positive pi over 4 and negative pi over 4, that makes one period. X equals negative pi over 4. Because from here to here is pi over 2. You get that?
So you always have to know like half.
What?
You always have to cut in half.
Yeah, so normally this would be negative pi over 2 to pi over 2, so but because the period instead of being pi is half of pi, right? So this is going to be one cycle of the function, okay? And since this is not shifted vertically or horizontally, you're going to have a point right here in the middle at 0, 0. Then when I get to the halfway point, which is what? What's that point going to be called? So this is very good. Pi over 8. Okay. Now, if I don't know what point goes here, I could plug in a point. Okay. So negative 3 times the tangent of 2 times pi over 8, which is the same as negative 3 times the tangent of 2 or pi over 4, right? What's the tangent of pi over 4?
1.
Net 1,
Yes.
right? Times negative 3 is going to give you out what?
Negative 3.
Negative 3. So over here at pi over 8, I'm going to go through negative 3. And which kind of makes sense because this is negative, so normally tangent would start down here and work its way up. But in this case, it's working its way down. So then you could just, by symmetry, go up here 1, 2, 3, and know that at negative pi over 8, I'm going to be at positive 3, and then I'm going to sketch in my curve. Am I going too fast? Well, that's not very good. It's not bad, but it's not. Oh, that's really bad. All right, but it should really have a point of inflection here. It goes more like that. Okay, so it changes concavity from here to here. You don't really know what that means yet, but it changes. Okay, and then it repeats itself forever like that. So you should do a couple cycles and even put in these points, which would be multiples in this case of pi over 2, I believe, right? Okay, negative pi over 2. And how do I know the asymptotes? Because you could just divide the asymptotes by the period divided by 2. Since I know the asymptotes are normally negative pi over 2 and pi over 2, I could just divide that by half and it squishes it by half. Yes, ma'am?
Why is the midpoint on the y-axis negative and not the, why is it the midpoint and not at
Why is this not here at?
never mind.
Because with a tangent, with cotangent, it starts here, right? Or with tangent, it
Negative 3. What is negative 3?
-3 is kind of like the stretch factor.
So what is N?
N is, where's N? Oh,
Where is it in the equation?
oh, and it would just be an integer. So,
Number, and that's how you graph it?
yeah, I think with this you just have to, I mean, normally it would be pi over 2, so the asymptotes are every pi over 2, right? So the next asymptote, if I add pi over 2 to pi over 4, so that'd be what? 3 pi over 4? Pi over 2 plus pi over 4 would be 3 pi over 4. So the next asymptote would be here at x equals 3 pi over 4. Okay? Yeah? Okay? Now we have to grab a cotangent graph. What are you doing?
Ben's got the paper, having fun.
Oh. Let's just do a cotangent one where we have to shift it. Okay? So, two x plus 5. Okay, so we'll just do this one kind of quick, then I'll be done because I know you want to get your quizzes and stuff back. Negative cotangent of 2x plus 5. So the period in this case is again pi divided by b. What's b in this case? 2. So it's again, the period is pi over 2. All right? Now there's a shift here. And this shift, the horizontal shift is going to be this number divided by this number. So that's c over b, right? So that's, and in this case this is positive, which means the shift is actually negative, also negative pi over 2. Got that? Yeah? Okay, now I'm going to graph kind of quick. I'm going to make solid lines because I don't like, got it? Good? Okay, like this, like this.
So is negative cotangent just the same as tangent?
Not quite. Yes, Randy.
Will you do horizontal shift real quick? Again, just
All right,
practice
so
what you're doing.
horizontal shift, this is C, right?
Yes.
This is B.
Okay.
So the horizontal shift is just C over B.
So that last
Okay.
equation you used didn't have it.
No, the last equation didn't have any horizontal shift. Now, since cotangent normally starts at y, this one is going to start at negative pi over 2 because it shifted left pi over 2 radians. So I'm going to graph an asymptote there at negative pi over 2, and we'll call this right here x equals negative pi over 2. Now, because that's the shift, right? Horizontal shift, it shifted left by negative pi over 2. And since normal cotangent, where's normal cotangent? It starts on the y-axis. So I'm taking that start point and I'm moving it back pi over 2 radians.
There would be an asymptote.
Okay? Changes where the asymptote goes. Yeah. Okay? So now, what's this negative going to do to it? It's going to go the other way. Okay? So instead of coming, cotangent normally it comes from the top and works its way down. This cotangent is going to start from down and it's going to go up, and it's going to do one cycle in pi over 2 radians. So since from negative pi over 2 to y equals 0, that is pi over 2. The y-axis is an asymptote in this case. If you want to graph some points, some other points, this would be negative. If this is, this would be negative pi over 4, right? since that's negative pi, this would be negative pi over 8. This would be negative 3 pi over 8. Negative 3 pi over 8. And those points, since there's no stretch factor out here, that would just go up to 1 there and down to negative 1 down here. Okay? So that's what y equals negative cotangent of 2x plus pi would look back. So Miguel asks, aren't tangent and cotangent just kind of flips of each other?
Yeah.
Not exactly, because tangent, remember, goes between negative pi over 2 and pi over 2, so tangent looks like that. Cotangent, yes, the shape of it is the opposite, but its first asymptote is the y-axis, so it's actually a shift and a flip. Okay, so that's the difference. All right, so I mean, I could turn a tangent graph into a cotangent graph by moving it forward pi over 2 and putting a negative sign in front of it, and it would look exactly the same. Yes, ma'am.
So does the horizontal shift the center of the?
Yeah, it chips the center of the. Yeah, it chips this point, because this is normally goes through.
Shouldn't the center of that one be
Um,
the first aspect?
The center be at pi over 2? No, because with cotangent, the center is usually at, shouldn't this, slow down here. Shouldn't this